Hello. Welcome to the Dreams portion of this stream. I am, as mentioned, I'm Liam. I'm a programmer at Media Molecule, and I'm working on Dreams. So over the last few weeks in our previous streams, we've actually been showing you quite a lot of the Dreams editor features. And obviously we don't want to show you too much too quickly because it spoils some of it for you and some of it for us. You know, we want to keep things fresh and exciting and keep things hidden and mysterious. So today we're going to do something slightly different. We're actually going to be playing around with Dreams coding. So we're going to be doing some live coding, adding some tiny features into Dreams. So these aren't necessarily going to be features that will make it through to the game itself. They might make it into the game but in different forms. In any case, it just the idea is that we'll give you a look into, you know, how programming works, what our processes are, and maybe just give you a bit of a flavour of what it means to be a coder. So I guess the question is, what exactly are we going to be coding? So a while back we actually had a feature that got lost somewhere in our iterative development process, because at MM we very much enjoy tearing down code and redoing it till it's good, or changing things up to be more powerful or more exciting or more fun. And often that means that we do drastic changes that lose us features. So actually Alex mentioned in a previous stream that roughly around June we actually tore down most of Dreams and rebuilt most of it from scratch, really, because we found that the core systems of Dreams that had been built up over the few years prior were actually not powerful enough to do the things we wanted. So we just sort of tore everything down and we pieced it back together again bit by bit. So some of the features we'll put in today were lost in that, some of them were lost before that or after that. So yeah, I guess the thing is sort of to get started. So the first feature that I want to bring back is one we had a little while back, and it's called the random brush tool. So at one point we had a tool that lets you place down, randomly search things from the world, from the Dreamiverse. So you saw in previous streams that what you can do in Dreams is you can go to an inventory, or you can search the whole Dreamiverse for anything you like. You can pick it and you can put it down in your level and assemble a whole scene out of those bits. But sometimes you're not quite sure what it is you want to search for, and it's quite nice to be suggestive things. So it'd be quite nice if you had a way of saying, just give me something, anything to place down, and let you sort of toggle and quickly request something new, something random to place in your level. So that's the first feature we're going to quickly add in. So we're going to go over to some code now. Don't panic too much, it might look a bit frightening. The thing to bear in mind is that I will be skimming over certain things. I'll be explaining certain things as I go along. If you have any questions, do ask, and if you're still not sure about something, ask me on Twitter afterwards or email me. We're always happy to answer any questions you have. So we'll go over to code now, and again, don't panic, it might look confusing, but I will explain a lot of it. So if my monitor will wake up. Okay, my TV has switched off, give me just a sec. So I can actually see the code that you're probably already seeing, I think. There we go, okay. It would appear that, there we go. So have we got that up on the, there we go, okay. Oh, yes. Sorry, just a sec, technical difficulties. So as it's to be expected, but from a live coding session, it's entirely possible that we'll actually have some technical weaknesses or bugs or whatever. Don't worry, we'll push through. So, over to the code. Again, don't panic, I will explain. Ahead of time, for the sake of going through this in a nice easy way, I've set up some code. So you'll find at points to the stream I'll be calling bits of code or functions or writing things that aren't necessarily shown here. That is just to speed things up, basically. So that is what these bits at the top are. So don't worry too much about those. So what we've actually got here, as you can see, we've got something called a random brush tool, and this has a bit of code called update. What this means is that over and over and over, the random brush tool will update and it will do this code. So there's a coding convention. If you're not a programmer, there's a coding convention that everything between this curly brace here and this curly brace here will run. That's a block of code that will execute. So every time update runs, whatever code we put here will also run. It's worth now testing that. One thing that's worth doing as a developer is, as you go, every time you add a bit of code, is to check that it's doing what you expect it to do. So actually what we want to do is make sure that this bit of code runs when we expect it. So if we go over to the PS4 quickly, you'll find that we go into a new dream. Ahead of time, I have sneakily added this button here. So you open the inventory and you see a little question mark, and what that is intended to do is to activate the random brush. So if I click that, you'll see we enter a tool, shown down here, and the idea is that this code that we just saw will run while this tool is active, but it's worth checking that. So let's do that now. So if we go over to the code, we expect that any code we put here will execute. So if we put something in that shows something on screen, we can tell when the code is running and when it's not. So we can say show message, and we can say something like, I am the random brush, and I am alive. And what I'm doing here is I'm writing C++ code. That's the programming language most widely used by the industry. And I'm writing it in a bit of software called Visual Studio, which is the environment we use to code. It lets us create C++ projects, it lets us debug, and one of the nice things it also lets us do is it lets us push changes to the game live. So without having to recompile the whole game, we can actually just send things straight across to dreams without having to close the thing, recompile and reload it. So now, if we push that change and go to the PS4, if we hit random brush, what we should see is a message at the top saying I am the random brush and I am alive. And if we close the tool, that goes away again. It's a basic check, but it's worth doing just to know that this code is running when we expect it to. So now it's worth taking a step back and saying, what do we want this code to do? What do we want this tool? How do we want this tool to work? And I think a reasonable design for this tool, at least as a first pass, is that you press a button and it gives you a random dream to place down. If you press the button again, it gives you a different random dream, and so on and so forth. So there's actually quite a lot of logic there. So let's break it down further into steps. It's worth sort of doing this as a programmer because it means that the code you write will generally be more reasonable and will be less buggy. So what we can actually do is we can write those steps down in the code and then actually fill the code out as we go. So if we go back over to the code and we get rid of what we've already got, we can instead add steps. So the first step, as described, is that when you're using this tool, if the user hits a button, they get a random dream. So the first step is, did they hit a button or not? So step one is check if the player pressed, and let's say for sake of argument, we use triangle. When they press triangle, we need a few things to happen. The first is that we want to activate the tool that lets us place things down in the world. So let's say that we actually call this the place tool. So we'll say activate the place tool. What we then need to do is get a random dream. And finally, we need to tell the place tool to use that random dream and let's put it down in the world. So we can say step 4 is tell the place tool to use the random dream we found. So step by step, we'll do it bit by bit. Again, if you don't understand things, please ask questions. But again, it's just a rough example. You don't have to understand everything, just as long as you get the general flow. So step 1 is check if the player pressed triangle. Now in coding, the bread and butter of coding is something called an if statement. It lets you do conditional checks. So it lets you say, has the player pressed a button? Have they opened the door? Have they turned on the light? Etc, etc. And the way you code that is you actually just write if, and then between these two braces you write the thing you want to check. And we want to check if the player pressed a button. So in that preset code I wrote, I've added a little function that lets me say if the controller pressed a button. And then we have to give some information to this question. When we're asking the system, did the controller press a button, we need to let it know a few things. The first thing we need to let it know is what controller are we talking about. If you've got multiple people creating in one dream, you've got a bunch of controllers. Luckily though, one of the things that we get up here is a controller. So you don't have to understand necessarily what all of this does, but the thing to understand about this update bit of code is that the thing between these parentheses are the things that we have access to. And the thing we have access to here is called controller, so we can assume that's a controller. So we want to say, has the button been pressed on that controller? And then we need to tell it what button we want to talk about. So again, if we say for sake of argument triangle, we pass that in and we tell it we want to check triangle. Now, we've done a check, but we need to run a bit of code if that check succeeds. If the user has pressed the button, we want to do a bit of code. So, as I mentioned before, there's a coding convention. There's a thing we do that says these curly braces are a block of code. if we place those curly braces under an if, it means everything within those braces runs if that check passes. So what that means is, if the player presses triangle, this block of code should run. Again, it's worth checking that and making sure that that does work before we move ahead. It's no use doing a bunch of steps, because then if a bug occurs, you have to check multiple bits of logic rather than just one. So here we can do the same thing we did before. We can show a quick message to say the user did press triangle or didn't. So if we add show message, and we'll have a brief one appear on screen saying you pressed triangle. And again, we push that to the PlayStation. What we should see is that when we switch to that random brush and press triangle, what we expect is that we get a small message saying you press triangle. So if we load up the random brush and we hit triangle, you press triangle, you press triangle, and you press triangle. So what we want now is that these additional 3 steps we listed go inside that block of code, because unless the user presses triangle, we don't want this tool to do anything. So we remove the message we just added, and we move these 3 steps into this block of code. Let's just get rid of white space, he's having extra lines. So the first step is to get the place tool. Now, we've already written that tool. There is already a tool in Dreams that lets you pick something from a search menu and place it down in the world. So there's no point in rewriting that code. What we want to do is reuse the code we've already written. So we've added, ahead of time, I added a function, which is a block of code I can call that already uses that place tool code. So I called that give me a place tool. And what this does is it will return us a tool we can use to place things down in the world. What we can also do, what it requires is a controller, because again, multiple people can be creating in one dream, so we need to tell it which controller we're talking about. So we give it the controller we've currently got, and then we need to store this, because it's no use getting the place tool if we just then forget about it again. And the way of storing things in code is we add things called variables. Now a variable is just basically a label on a bit of information. So we want a label on this place tool we just got so we can refer to it later. So we call this thing place tool, and it needs to know what type it is, so we give it a type, which is place tool as well. If you're a coder, you might know what the star means here. If you're not, ignore it, it's not important. And the way we give that label a value is we use equals. So what this means is take the label I put on the left, place tool, and basically give it the value on the right, which is the actual tool itself. So again, the third step, get a random dream, that follows exactly the same pattern. What we want to do is say give me a random dream, and then what we need to do is we need to store that again. So dreams have a different type, they use IDs, and we can store that and call it dream. So now we've got a place tool and a dream. And the final step is actually the easiest. We just need to tell the place tool, I want you to place this dream in the world. So we take place tool and we can tell it things. And the first thing we want to tell it is we want to use a given dream. And then again, between the curly parentheses, we just basically say dream. We've labeled it up here. So we're taking this bit of code, this thing we found, this random dream, and we're basically telling the place tool to use it. So now, that is pretty much the entirety of that tool's logic. If we push this to the PlayStation, what we expect is when we hit triangle, we get a random dream and a place tool which puts it in the world. So let's do that now. If we push that, and then we go over to the PlayStation. You should find that when we hit triangle, we get a random dream on the end of our brush. So we get a sculpt like a head, we get an archway, we get a bit of floor, so we put the floor down and we can start building a level. And we hit triangle again, we get a stool. And it's just picking random dreams from the entirety of the Dreamverse, things people have made. We've got like a robot head, we've got like a... one of our artists, Menlu, recently made a sculpture of Bruce Lee. So we'll put him in our level because that can only make it better, surely. An eyeball and a very giant head. So let's just place Bruce Lee's head like that. So maybe some clouds to put in the level. I mean, you get the idea. We can sort of slowly build up a scene based on just random things we pull in. And you know, we just... And you know, already, like, if you like, the code itself is... The code we wrote was about 5 lines. But what this gives us is a very interesting sort of powerful tool to just give us things to play around with in a very sort of serendipitous way. We don't really have to think too much about what we're making, we just let the Dreamiverse suggest it to us. So like a ship and a robot head, so if we place that robot head on the ship, we sort of get a Cylon Raider type thing. We can group those, and then we've got Cylon Raiders. So yeah, you get the idea. I mean, we could hammer the random dream button all day if we really chose, but I think it'd be more interesting to basically do a different feature. There's Anton, who was on the stream last week, has a fondness for making birds with arms. So yes. Yeah, so that's one feature, and it was just sort of a quick taste of how quickly you can put together a few simple bits of logic to get something really interesting happening. And you sort of saw that the process there is you sort of have to figure out what you want to do, design it in steps, and then write the code that does it, and then test. And luckily, it worked first time. Thankfully, live coding is a bit of a danger, but it did work first time, so we're all good. So I think the next thing to do is sort of find another feature. So one that I have in mind and that I want to try out is actually best represented by going into a scene I've set up ahead of time. So if we go back to my dreams list, my personal profile, I've set up this list of this dream ahead of time. And all that's in it, and it loads, all we have in this dream is a few bits of checkerboard flooring and some crates. And what you expect, just looking at this level, is when I hit play, I expect that the crates are going to start falling, because crates do that, right? And I do, and actually only one of them falls. And that's a bit confusing. I can't really tell why, I can't really tell how I make the other ones fall. So actually in dreams we currently do have a way of making things physical or not, make things fall under physics, tumble around or not. So what we probably want is that the floor is static, it stays in the world, it doesn't move. But we want the crates to be dynamic, they can be grabbed, they can fall, they can tumble across each other, they can collide with things. So what we want to do is make a tool that lets us make things physical or not physical. And again, it's worth at this point stepping back and thinking, how do we want this tool to work? Because this one is a little bit more complex. I think the reasonable steps to take in this case is you want something that you can hold. So you select a tool from the menu, let's call it the physics tool for the sake of argument, and when you hover over something and click it, let's say if it's already physical, it becomes static, it becomes stuck to the world. If it's already static and stuck to the world, instead it'll start falling. So again, the first thing to do there is actually to write out the steps in that logic, because it is quite complicated. So let's go back over to the code and start writing those steps. Again, ahead of time I've sort of set up the skeleton of this, and the skeleton of this is actually very similar to the random brush skeleton. You've just got a tool called physics tool, and it's got an update that means when this tool runs, run this block of code here. And again, it's given a controller to work with, because that way you know which player is using the tool. Again, I wouldn't worry too much about any of this or anything up here, unnecessary. But let's start writing out the steps for the tool we've just proposed. So step one is to check what we're hovered over. Now we're using a tool that has to click on things in the world. So the first step is to find out what thing we mean. So step one is find the thing we're hovered over. Now step two is presumably we want some sort of interaction. So we want it that when you click an object, something happens. So step two is check, again, just like with random brush, we need to check if the player pressed something on the controller. In this case, I'm going to tie it to the trigger. So check if the player clicked the trigger is step two. Step three is then to update whether the thing is physical or not physical. And there's actually a lot of logic in there, but for now we're going to write that as one step, and then we'll break it down when we get to it. So the third and final step is update whether the thing is physical or not. So let's go through this bit by bit, and again, testing as we go. It's important to do that because otherwise we'll have to end up debugging a large amount of code rather than just one or two lines. So the first thing is to find the thing we're hovered over. For the sake of time, again, I added a function beforehand that we can use to find the thing the controller's hovered over, and that is just called find or get hovered thing. Yes. And that expects a controller. Again, if you've got multiple people in the level, they can be hovered over different things, so we need to know which controller we're talking about. So we give it the controller we think we've already got, and we store that. We store it in something called thing, and we also need a type. And the reason I've called this thing is because that's exactly internally what we call all the things in the level. In the scene you've seen, we've got a bunch of floor panels and we've got a few crates. Now in the code base, all of those are things. So the type for that is thing. It's actually thing PTR, but don't worry too much about that. All that means is we're getting a thing in the world. So step one, done. We've got a thing. But it's worth checking. There's no point in doing the rest of the steps until we know we've definitely found the thing we've hovered. So let's check by doing something like making the thing we hovered a different colour. That's a nice visual way of showing what we've hovered over. So there's a function again for that. There's a bit of code we can call that is just called set highlight colour. And that requires two things. It needs to know what thing we want to highlight, and it needs to know what colour we want to apply to it. So again, we give it the thing we've hovered over, and then we need to give it a colour. Now the way we represent colours in the code base is by combining four numbers: red, green, blue and alpha. Each of those goes from 0 to 1. 0 means none and 1 means all. So if you give it 0 for red, you'll get no red. If you give it 1 for red, you'll get lots of red. And we actually combine that into one thing. I wouldn't worry too much about the naming, but internally what that is called is float4. If you have more questions about that, feel free to ask me after the stream, but I'm going to skim over what that means, what the implications are. All you need to know is that between these circular braces, what we want are four numbers: red, green, blue and alpha. So we give it red of 0, green of 1, because let's say we want to turn the thing we've hovered green, and we give it no blue and full alpha. Now, those of you that have already have been coding for a long time, or have tried coding, or even those of you that haven't, that are sort of keen-sighted, you might notice that this has a slight problem. The problem here is that we're getting the thing we hovered over and we're tinting it a colour. But what if we're not hovered over anything at all? What does the code base do then? Well, it turns out that actually what the code is likely to do is get angry and crash. So it's worth making sure that we only set the colour if we found a thing under the cursor, if we've definitely hovered something. So the way we do that, again, is a conditional check. We check something, so we have to do another if statement. So what we do here is, before we set the highlight colour, we check if the thing we just stored under the label thing is definitely valid, if it's definitely found. And the way we write that in our code base is if the thing is valid, and then again we do these curly braces afterwards to do a bit of code that runs if we've hovered something. So in this bit we can say this code runs if we hovered something. And we want to move our highlight in there so that it doesn't crash if we haven't hovered anything. So now, again, it's useful to test as we go along. If we push that to the PlayStation 4, what we expect is that when we hover something, it turns green. Oops. So, if we switch to the physics tool, which I again sneakily added beforehand with this little seesaw icon, we expect that when we hover things, yep, they do indeed turn green. Great, so that bit of code is working. Now the question is, what does the tool do next? Well, the next thing is we've hovered something, but we need to click it. So we want to check if the user hovers and they press the trigger, that means they clicked that object. So the next thing to do is check whether the user clicked the trigger. So we only want to do this check if we did hover something. So we move the following steps inside the block of code that runs if we hovered something. So those steps go as follows. We already saw in the last file, in the random brush example, how we check for input. We just say if, but with triggers it's slightly different. Because we've got a controller, we can check directly on the controller the trigger, and the trigger has a bit of information we can grab from it, which is called clicked fully. Because what we want is that you have to take the trigger fully down before a click counts. So again, we put in those curly braces again because we only want to do things if you click. So we move this step again inside there because we only want that bit of code to run if we click. So as with previous steps, we want to check as we go along that we've definitely clicked a hovered thing. So the reasonable way to do that is, again, show another message on screen. So we write a bit of code that says show message brief, and we say you click something in big capital letters. And we push that again to the PS4, and in a few seconds, once that's updated, we can test this out. So you'll see now it's hovering green, but we've removed, no, we haven't removed the green bit. So if we click now, we should get, you click something, you click something, you click something. Great, so the code is working so far, the tool is doing as intended, but its main bit of functionality isn't there yet. So for now, let's remove our tests. We know this works, so there's no point in keeping those around. So we can remove the highlight, and we can remove the message. And instead we can just focus on step 3, which is actually the most complex bit of logic. What we want to say here is, if the thing is physical, if it's already falling in the world, we make it freeze, and if it's frozen, we make it physical, so it will start falling about. So again, the keyword there was if. We've already said we want to check something, and the thing we want to check here is, was the thing we clicked physical or not? So the bit of code we add there is, again, there's a preset bit of code that says, is the thing physical? And we add a block of code. And this is great, we know that this code runs if the thing is physical. But we hit a problem here, because what if the thing isn't physical? What do we do in that case? Well, if has a companion, which is called else. And what else means is, it goes up to the if that's above, and it says, if that isn't true, so if the thing isn't physical in this case, then instead run a different bit of code. And again, we put those between curly brackets. So what we can say here is, this code runs if the thing is not physical. Great. So now we know where we have to put that bit of code, but we need to actually change the world. We need to make the thing fall about or stick to the world. So we do that, again, with another bit of code preset, which is make thing unphysical. So in this case, we know that the thing is already physical, and so in this case we want to make it unphysical. We want to make it freeze in place. So we say make thing unphysical, and we tell it what thing we mean, which is the thing we hovered and the thing we clicked. And as the counter example, in the else statement, we say that if it's stuck to the world, like most of the crates are in this example, we make it physical, and it should start falling immediately. As long as time is running, it will fall. So we can push that to PlayStation and test it out. So just as a reminder, if we hit play, what happened was one crate fell. The rest of them are not physical yet. So if we stop time, rewind and hit play. Now if we go back to the physical tool, what we expect is that if I click one of these crates that is hanging midair, it will fall, and hopefully it does. And while it's falling, if I click it, it should freeze, and so on and so forth. So there you go, that's another tool. Again, not many lines, this is probably 7 or 8 lines of code. Not very complex, but it's worth going through the process of figuring out how exactly you design that sort of thing, how you test it. It might give you a sort of flavour of what it means to do some programming. So the flip side of programming is design. Now it's very easy to say, look at this example and say something like, well, it works, it's done as we expected, so we can leave it there. The problem is that this doesn't feel very good to use. It might not be designed very well. It doesn't give us a lot of information. So you might think that the problem here is that I can't tell at a glance what things are falling under physics and what aren't, because that crate that's already fallen is sitting on the floor. I don't know whether that's physical or not. So the next useful step might be to show the user what things are physical and what aren't, so that when you use the physical tool, you get more of a sense of changing the world. You can see something happening, you can see something changing. And the best way, I think, to do that is just to add a colour overlay. So make things a certain colour if they're physical, and a different colour if they're not. So let's do that now. So it's worth, again, designing the steps for that. So what we actually want to say is, go across all the things in the scene and set their colour. If they're not physical, set them to one. If they are, set them to another. So if we write the steps in the code, what we want to say is, step 1, go across all the things in the scene. Step 2 is, if the thing is physical, set it to, let's say it's set it to full colour, so it's just whatever colour it was originally. Step 3 is, if the thing isn't physical, let's say we set it to black, because that implies it's inactive and not doing a lot. So you'll notice I've placed this block of code between these curly braces, but not between any of these. That's because we want this code to run regardless of whether or not we're hovered over something, regardless of whether we've clicked something. This code should run all the time while we're in the physical tool. So, step 1, we have to go across all the things in the scene. Now this is actually one of the parts of the code I'm going to skim over a little more. Explaining it would make the stream a lot longer, and is probably would just bore a lot of people, I suspect. So the key thing to take away here is there's another programming construct called a for loop. And what a for loop does is it lets you do something multiple times. In this case, we want to do something once for everything in the scene. So we write that like this, and again, it's not worth worrying too much about what this code actually does, because it would take much longer to explain. The key thing to take away is that this essentially goes across all the things in the scene. What this means is in this block of code we can say this code runs once for all things in the scene. So whatever we do in there happens to everything in the scene. So our steps need to move inside that block. So now we want to change colours. The easiest thing to say is, again, it's another if check. We've said if it's physical, do this, otherwise do this. So we say if is thing physical, same bit of code we used up above, we give it the thing, and in this case the thing is coming from the for loop. So the for loop takes the label thing and it changes what it means every time you go around this loop. First time you go around it gets, say, a crate, the next time it gets a floor panel, the next time it gets the next floor panel, and so on and so forth. So every time we use thing in this block, it will mean a different object. So here we'll say, if the thing is physical, do one thing. And again, we bring back the thing we did above, which is an else statement. So we've got a block of code here that runs if the thing is physical, and a block of code here that runs if the thing is not physical. So the question now is, how do we change the colour? Well, we already saw how to do that in the debug, in the test we did, where we were turning things green. There's a bit of code you can call called set highlight colour. And what that does is, again, takes the thing and it takes a colour. So because this is physical, we want it to be full colour, so we say 1, 1, 1, 1, full red, full green, full blue and full alpha. And in the case of not physical things, we want to say set them to black, which is no red, no green, no blue, but alpha. And so now if we push that to the PlayStation, what we expect is that while we're in the physics tool, the whole world changes colour to show what things are physical and what things aren't. So if we run the physics tool, oops, brilliant. So what you can see now is that everything's gone black except for the two crates that we know have already become physical. So what we expect now is actually if I click things, they'll gain colour and they'll start falling. Great, it works as intended and also gives you a little bit of useful information. So stop time running, rewind, and for usability let's leave the floor in place. Great, so now we've got a level, we can hit play mode, and what we get is crates stumbling around. We can grab them, throw them around, we can pretty much just mess around with the level as we like. But notice the ground stays in place, I can't grab that because it's not physical. And great. That's like a full feature. Now we can take this as far as we want, and really it depends on how much interest there is in the stream, but I'm happy to take any questions, and we've got one coming in, I think, which is, what's your background? So I think this is a question I've been asked a few times actually about sort of how I got into games and became a programmer at MM. So personally I went to university to study computer science to learn programming, because I'm quite a technically minded mathematical person and I enjoy games. So my ultimate aim was always to become a games programmer. But there are a lot of different options for getting into programming in the games industry. There are a lot more games specific courses springing up, and the choice between, say, computer science, which is very theoretical and very broad in its application, versus something like a game specific course, is actually a choice that a lot of people will have to make if they want to become a games programmer. There are plenty of articles online that discuss the difference between the two, and actually which one you take matters less than what you do while you're there. It's very critical. If you want to become a games programmer, the key thing to do, regardless of where you're learning, what degree you're studying, the best way of getting into games is to make games. Whether that's doing art for them, whether that's animating, programming, there's no better learning experience, there's no better way to teach yourself how to make games than just making one. There's no better way of showing your enthusiasm or your ability than having a games portfolio. So my recommendation, if you're interested in looking into getting into games, is to make them. Unity is very good to start with as a program. It's very easy to get started in programming, and yeah, the key thing is really should be making games. If you have any more questions about that specific thing, feel free to send me an email or get in touch with me on Twitter afterwards, and I'll be happy to elaborate more. There's a question: is there a limit to the number of physical objects you can have? The answer, as with all things technical, is of course. Unfortunately, we don't have unlimited power processing yet, so there will always be a limit to what you can have in your scene to a reasonable degree. But of course, we want to set the limits of the scene such that you get some, you can have as much freedom as you want. We want to give you the ability to have lots and lots of physical things. I'm not going to put a number on it because that's a very bad way of committing to certain requirements, but yes, you'll have a lot of freedom with the amount of physical things you can put in your scene, yes. Are we using our own physics engine? We're using a lot of custom physics code. Critically, this is because if you've looked into the tech, if you've gone and watched Alex Evans, our technical director and graphics guy, there's a video on our channel on YouTube of him giving a talk about how we do sculpts, how we have worlds, and we actually do things in a very non-traditional sense. We don't use polygons like most games. We actually use clouds of points, which most physics engines don't support. We've had to very specifically tailor our physics needs to deal with the fact that objects aren't made out of polygons, and that's usually how you do collision. You check collisions between polygons. We can't do that. So yes, we do a lot of custom physics, but we also potentially use some middleware underneath. What's my favourite game? That's the worst question to ask someone who's into games. I don't know that I've ever met a gamer who likes answering that question. Purely in terms of if I had to choose one based on the amount of time I've dedicated, World of Warcraft, just because it consumed a few years of my life and it's still got a special place in my heart, so I'd have to say that. But I don't think I'd ever go back. So, I mean, there's potentially more questions coming in. I think one of the interesting things now actually might be to just sort of maybe extend the code a bit, maybe sort of skim over some of the code and just do some quick stuff to get interesting things happening, show you the sorts of things we can do in the code base. So actually, in playing this level, one of the things I initially noticed was when I grab these crates and throw it about, it's sort of a bit more floaty than I'd like. Like, I kind of want it to be a bit more, to fall a bit faster. So one of the things we can do in code is just to up the gravity. So let's try that out. So what we can actually do in the code base is we can set the gravity on specific objects, and it's useful to do that because if we want to set the gravity on all things in the level, it takes up more processing time than is necessary. Instead, what we would actually prefer is just to only set the gravity on the things that are dynamic. So we know where that code runs, we've already seen it. There's a bit here that highlights something if it's physical. Instead, what we want to do is we want to say, if you're physical, also up the gravity a little bit. So there is, again, another bit of code that already exists that we can call, which is called set gravity factor. And it takes two things. One is the thing we want to change the gravity on, and the other is how much gravity to apply. Now by default we're applying gravity of 1. Anything above that makes things fall faster, anything below makes things fall slower, or even upside down. So let's try applying gravity of, say, 1.5. 50% more gravity on things. If we again push that to the PlayStation 4, we'll find that we can get... Was that updated? If we grab things and let them go now, they fall a little bit faster. Not much faster, to be honest. So what we kind of want is the ability to be able to update the gravity without constantly pushing changes, because that takes a small amount of time. Instead, what we want to be able to do is quickly modify that. So I'm going to add a bit of code here and I'm going to skim over what it does exactly. But essentially it gives us a display on the PS4 that lets us change values. So one of our ex-programmers, Omar, set up something called IMGUI, which is a very useful system for essentially just adding displays on the screen which lets us twiddle with things. So we're going to have one that's called gravity. It'll give us a panel, so it starts here and ends here. And anything between this gives us some stuff in that display. And one of the things we can have in there is a slider, and we'll call that gravity slider. And we need to give it a value. And the value we'll give it will store up here as a variable, and we'll call that gravity, and we'll start that off at 1, let's say. Again, I'm skimming over a lot here. the thing to note is just that this is a way that will quickly let us change this value. So we give it the gravity to change, and we can give it a minimum and a maximum. And let's say we go from -2 to 2. Now, when I run this code and push it, the problem is we haven't actually used this gravity anywhere. So what we actually want to do, if we switch back to the code quickly, is we want to put this gravity value into the bit of code we just wrote below. So we replace this 1.5 with the gravity variable. So we've put a label on a value, and we set up a bit of code that lets us twiddle that value quite easily. So now, if we update this code and push it to the PlayStation 4, we should get a panel on screen that essentially has a slider that changes that gravity value. So if we move, we have within our studio we have a bit of software called Synergy, which lets us move the mouse over to the PlayStation screen, as you can see here, so that when we get a debug display up, if we go back out and into the physical tool, you see, let's just start time playing so things fall around. You'll see there we've got a window, and it has a slider called gravity. I don't know if you can see that, but it is labelled gravity, and it starts off at 1. Now if I move that towards the negative, you'll find things start floating upwards. If I move it super down, they fall down fast. If I move it super negative, they fall up super fast. And this is just sort of a quick flavour that I wanted to give of sort of the tools are really what let you do very quick development. As programmers, we like finding quick ways of changing things and not having to wait for compiles and not having to do a lot of effort to get fun things happening. So this is just a nice example of something you could do. So again, yeah, I hope that's been entertaining of some form. Entertaining in some form. I hope no one's got too confused. If you have any questions, again, send me an email, get in touch with me on Twitter. I am Kilobytes, that's KILO_BYTES. Just send me messages and I will answer whatever questions I can within reason. Yeah, I think that's probably about it for now. Hopefully, yeah, it's been interesting, and yeah, let us know what you think. This was a very experimental stream, so yeah, feedback's good, and let us know whether you want to see this sort of thing again. Yeah, so bye for now. Bye.